Hi Professor, this is me Jeevan. This is my video presentation demonstration for CLO85 assignment 2. In this video, I'll be demonstrating deploying and managing a containerized application on a Kubernetes cluster running on AWS. The goal is to deploy and manage a containerized application on a Kubernetes cluster. Before I begin the deployment, let's quickly review the setup. Let me go to my ECR first, repositories. Here I have already pushed the Docker images for the web application and MySQL database. Here in this I have version 1 and version 2 image tag. Now let me show you my GitHub. Here it is showing the sequence of commits, these are the commits for creating the Kubernetes manifest files. And Cloud9 is running on EC2 instance where I'll be running the Kubernetes cluster. Now let's begin the demonstration by verifying the cluster status. First, I'll verify that my single node Kubernetes cluster is running correctly. For this, let me run the command get nodes. This is working fine. Confirms that I have a single control plane node and its status is ready. Now next, get all. This shows that all the core Kubernetes components like CoreDNS and the API server are up and healthy. Now let me run the another core cluster info. Yeah, finally the cluster info gives the address of the Kubernetes API server. As you can see, IP address is 127.0.0.1 and running on a random port number. Thus the cluster is ready, and now I'll proceed to deploy the applications. Now I'll deploy the web application as a standalone pod because I'm in a restricted AWS environment. I must first create a Kubernetes secret with ECR repositories, credentials. I'll apply the namespace and then secret, and then finally the pod manifest. I tried it multiple times as I was having an issue. So let me copy my code to apply the namespace. Namespace for web and MySQL created. Apply the secret. This one is done. Now main part, deploy the web app pod. Web app pod has been created. I'm checking the status. Again, I made some changes since I was having an error. So let me copy this one again. Web production created. I am expecting that it will work now. CTL get parts. Now it's getting the crash loopback error. Since I was having the cryptography package issue, I resolved it. Now it's running, so let me show it. It's finally running. Now let me connect to the server. Since it is having issue with the call, and like most probably it is due to the port issue. Let's do the port forwarding, and from the next terminal let me as you can see, we received a valid HTML response. Next, I'll examine the ports logs to demonstrate that this request was registered. This one, as you can see, the logs show the get request with a 200 status, so this is working fine. Now I'll clean up the standalone part and deploy the applications using replica sets to ensure a specified number of replicas are maintained. Let me just clear this one, delete the standalone part, then apply the replica set. Replica set created. Replica set created for MySQL. Now let me get if. As you can see, as I mentioned in like demo app replica set, we have replicas, 3 replicas, and here we got 3 replicas, so this is working fine. Now for MySQL replicas, let me paste it. Similarly, in the MySQL NS namespace, the MySQL replica set shows already count for 1, and you can see its corresponding single pod is also in a running state. This demonstrates that the replica set controller is working as expected to maintain our desired number of application instances. Now I'll clean the manual replica sets and deploy the final versions using deployment manifests, which are the standard for managing stateless applications. Let me first clear this one, delete the replica set, delete it. Content. Let me also apply this one, create it. You can see it's working. Also, let me get MySQL. So yeah, this part is also done. Now to make the application accessible externally, I will apply the service manifest. MySQL gets an internal cluster IP service, and the web app gets a NodePort service on port 30,000. I'll test it first with the call and then from a browser. For this, let me clear this one and apply my service.sql, then my web app, now get all the namespace. You can see Kubernetes, kubedns, MySQL service, and web service. Now Maybe this is the issue with the port forwarding, so let me put forward it. Then for my terminal, call host to 30,000. Yeah, as you can see, we get the HTML page. This shows that it is working. Now I'm going to access it via the external browser. So let me open the incognito window. S2 30,000 content site. I'm not able to access it because port forwarding only works for the terminal, but to make it accessible by the external browser, I need to like create once again the kind cluster. For now, I'm not doing that. I'll proceed with the another step. Finally, I'll perform a zero downtime rolling update. I'll edit the web apps deployment manifest to change the image tag from version 1 to version 2. For this, I'm going to open this one, and here place up version 1. I'm changing it to version 2. Control yes. I'm going good here and apply my service.yml. I did a mistake, so I need to deploy web app deployment. This is configured. Now let me copy this one, and it shows that web app deployment successfully rolled out. Now describe parts. Image, as you can see now, the image shows it's using version 2 web app. Now I'm performing call localhost 3000. See, I think the port forwarding connection is lost, so I need to rerun it again. Then again perform the call. As you can see, I'm getting the same content. This shows it is working fine and shows the perfect rollout. Finally, to access the web app by the browser, I like deleted the kind cluster and again installed it using the kind config YML, and then did the necessary configurations, and then with the IP address and the port forwarding, now I can access the web app by the browser. Let me do this slash true. This proves that I can access it via the NodePort. Now again to show the rollout, I'm changing again version 2 to version 1. Yes, then go here. Now apply the changes. This one done, and Since it's successfully rolled out. And lastly, now it's showing the version 1. Now let me refresh my browser tab. As you can see, it is reflecting back to the same web app, so it is successful. So to answer the final part of the submission requirement, we use different services for the web and MySQL applications to follow the principle of least privilege and ensure that the proper network security within the cluster. MySQL database uses cluster IP while keeping it private and secure, accessible only from inside the cluster, whereas the web application uses NodePort, which exposes it to the public internet, so users like us can access it. So to finally show my GitHub commits, these are the commits that I have done. As you can see, these are the commits. This concludes my video presentation. Thank you.